In section 4, we're going to really start getting into some systematic ways of solving quadratics. And I think you'll find that this section hopefully is a little bit more straightforward than maybe the last section with solving by graphing. Solving by graphing, again, as I indicated in class, is not necessarily going to be the most efficient way of solving these quadratics. Okay, so today what we're going to look at is using square roots to solve quadratic functions. All right, so here's what we're looking at. So if we want to solve this thing, all right, the good news is I only have one x squared in the problem, so I can solve this pretty simply by, let me go back here. If I go divide by 3 on both sides first, cancel, so I get x squared equals 25, and now I got to get rid of the squared, so I take the square root. Remember, when you take the square root, you got to say plus or minus. So in other words, the answer here is not just 5, it could also be negative 5. Okay, because think about it, negative 5 squared, negative 5 times negative 5 is positive 25. So again, when you put in the square root sign, you have to consider the positive and the negative root. Okay. Part B, I'm just going to fly through these, okay? And again, my encouragement to you would be to pause the video if you think you have a handle on it and you want to try it on your own. And if not, then you can keep plugging along with me here on the video, okay? So add 15 to both sides. So I end up at 2x squared equals 0. Divide by 2. So x squared equals 0. Square root, x equals 0. Now in that case we should have said plus or minus, but again, positive 0, negative 0, it's all 0, it doesn't matter. Okay, so in that particular example, there's only one answer, there's only one solution. Alright, and then we come here and I say, alright, x squared plus 5 equals 3, and so I say minus 5, so I get x squared equals negative 2, square root, x equals, well, now we say, wait, square root of negative 2. Okay, there's no real number that represents the square root of negative 2, and so your answer here would very simply be there are no solutions. Okay, and again, let's just really quick think about this for a second. If I look at this equation here, okay, and I pull this 3 to this side, all right, then it would end up saying x squared plus 2 equals 0. All right, well, x squared plus 2, I can graph that, right? X squared plus 2 just means take your original graph, move it up 2 units, and it's a normal parabola, so it looks something like that. And we can see this thing never crosses the x-axis, so it should make sense that there's no solution there. Okay. And then we're over here, part D. All right, so we're going to add 25 to both sides. So I get 49x squared equals 25. I got to get everything to one side, so divide by 49. So x squared equals 25 over 49. I got to square root both sides. So x equals the square root of 25 on top is 5. The square root of the bottom is 7. And again, we can't just say positive. We also have to consider the negative root. Okay, so those will be 2 solutions here of that particular equation. All right, again, we're just going to keep plugging away here. I'm going to keep going through this video. So divide by 16, x squared equals 9 over 16. Take the square root of both sides. So x equals 3 over 4 or negative 3 over 4. Could be either one. Again, no issues here. I think that you're going to start getting the hang of this now. So we're going to subtract 18. 5x squared equals 0. Divide both sides by 5, so x squared equals 0. If I take the square root of 0, my answer is just 0. Okay, so again, there's only one root there. We'll do part G, and then we'll move on here. So part G, we'll add 9 to both sides. Okay, so I get 4x squared equals 100. Divide by 4 on both sides. So I get x squared. 100 divided by 4 is 25. Take the square root of both sides, so x equals 5 or negative 5. All right, and again, you guys can keep plugging away there with h. I guess that's the last one there. So, so anyway, predicting the number of solutions. Okay, if your d is bigger than 0, then x squared equals d has 2 solutions. Okay, plus or minus the square root of d, where d is just some number. Okay, if d equals 0 when I solve, then it has one solution and it's just 0. And if d is less than 0, in other words, it's negative, and I take the square root of a negative, that means it has no solution. Okay? So, example 2 says, give the exact solution and an approximate solution for each. Alright, so when I go through here, I subtract 4, I get 2x squared equals 9, divide by 2, so x squared equals 9 over 2. Alright, now this number is bigger than 0, so I know I have two answers. I got to take the square root. So the exact solution, alright, would be the square root of 9 over 2 and the negative square root of 9 over 2. Okay, and I could have, what I probably should have done there, and I don't know if we've talked about this in class in algebra, but we will review this in class. If I have the square root of 9 over 2, that's the same thing as the square root of 9 divided by the square root of 2. And we know what the square root of 9 is. That's 3 divided by square root 2. And I don't know if you've talked about this in a previous course, but you can't have a square root in the bottom. So we have to do what's called rationalize. So we have to multiply the top and the bottom by square root of 2. And so we end up at 3 square root 2 over 2. And that's really the same thing as this, except the 3 root 2 over 2 is in simplest form. Okay, is in the reduced form. So these are my two solutions. The approximate solution, all you're going to do is plug these into your calculator and get a decimal. Okay, I'm not going to do that. The assumption is that you can plug stuff into a calculator. So we'll do this one together here. So add 3. So I end up at 4x squared equals 3. Divide by 4. X squared equals 3/4. And so I take the square root of both sides. So x equals the square root of 3 over the square root of 4. I know the square root of 4, so that's square root of 3 over 2. And again, I can't just take positive. I also have to take negative. So I have square root of 3 over 2 and negative square root of 3 over 2 are my exact solutions. Plug those into your calculator, and you'll get your decimal, your approximations. All right. The next one there, you can kind of work through on your own. The next couple really, we'll do this one together, part A here, example 3, part A, because it is a little bit more difficult. So what I have to do is, the first thing I would do is I would just divide both sides by 5. All right, so I divide by 5, and I end up at x minus 3 quantity squared equals 7. And then you can take your square root, and so you end up at x minus 3 equals the square root of 7. Add 3 to both sides. I really should say plus or minus 7. Add 3 to both sides, and so you'll see here x equals, it could be 3, I'm sorry, let me rewrite this, square root of 7 plus 3, or negative square root 7 plus 3. And again, you take those two solutions, plug it in to your calculator, and get your approximation. All right, some of you might be tempted to FOIL. You don't have to FOIL there if you can cancel out the square root right away, or the square, I mean. So again, divide by 2, so x plus 1, quantity squared equals 5. Take the square root of both sides, so x plus 1 equals plus or minus the square root of 5, minus 1, minus 1. So the exact solution would be square root 5 minus 1, or negative square root 5 minus 1. Those are my two solutions. Plug them in to get your exact, or your approximations. All right, so vertical motion model, this is just something that we'll talk about. It's more of a science thing, but it says h equals negative 16t squared plus vt plus s, and it tells you right here, h is the height, t is the time, s is the initial height, and v is the initial vertical velocity. All right, so it says use the vertical motion model to determine the following. An object is dropped from the top of a 40-foot building. Approximately how long will it take the object to hit the ground? Okay, so what we'll do is we'll just say the height is 40. Okay, let's see here, what does it say? All right, so what you have to understand here is h is the height, the final height. Okay, so h is I'm sorry, not 40. It says hits the ground, so when it hits the ground, it's at 0. The s was the initial height. Okay, and so s, the initial height, is obviously 40 in this particular problem. Okay, so if I look at this, our model is h equals negative 16t squared. So h equals negative 16t squared plus, what does it say, st, vt, plus s. Okay, and so we know h is 0. We know we have negative 16t squared plus, we don't know our initial velocity. Well, we do know our initial velocity. Our initial velocity, when I'm holding it at the top of the tower, is 0. So 0t plus 40. And so here's where I end up. I have 0 equals negative 16t squared plus 40. So I subtract 40 from both sides. Let me extend the page a little bit. Whoops, a little bit too far. So I have negative 40 equals negative 16t squared. Divide both sides by the negative 16. And so I end up at t squared equals, well, the positives are those are going to cancel. 4 goes into both these. 4 goes into 40 10 times. 4 goes into 16 4 times. 2 goes into both of those, 5 and 2. So I have 5 over 2 square root. So t equals the square root of 5 over 2. Okay, now we should say plus or minus, but it should make sense here. The question is, how long will it take? You can't have a negative amount of time, okay? So we would say square root of 5 over 2 is how long it would take. Okay, square root of 5 over 2 doesn't say units here. So we'll just say the square root of 5 over 2 since our units are not specified. All right, so again, just a way that these quadratic equations can be applied to different situations. So bring questions tomorrow to class, and we'll take those first thing.